Assalamualaikum. Today we will present a group assignment. The topic is about feet. There are two types of feet, which is junction feet and morph feet. The junction feet can be used as an electric control switch. The electric energy flows through an active channel between source to drain terminals. By applying a reverse bias voltage to the gate terminal, the channel is strained so the electric current is switched off completely. MOSFET is a P-type semiconductor but with a metal oxide layer deposit on its surface and holes taken out of the layer to form source and drain terminals. Can be used as a switch. This type of FET has three terminals which are source, drain and gate. The voltage applied to the gate terminal controls the flow of current from source to drain. The diagram shows basic structure of feed. We can see there are three terminals which are drain, source and gate. There are two depletion layers. There are two symbols of defeat which is N-channel defeat and P-channel defeat. There are four symbols for MOSFET which is N-channel enhancement type, P-channel enhancement type, N-channel depletion type and P-channel depletion type. Operation of field effect for JFET is a current can flow through a JFET. If the wider the JFET, the greater the current can flow through it. The channel becomes a small pipe when there is no voltage across gate and source. For MOSFET, controls the voltage and current flow between source and drain. MOSFET depends on the semiconductor surface below the oxide layers. It can be inverted from P-type to N-type by applying positive or negative voltage. Construction of defeat. The N-channel defeat consists of P-type material and N-type substrate, whereas N-type materials are used in the P-type substrate to form a P-channel defeat. Defeat is constructed using the long channel of semiconductor material. Depending on the construction process, if the defeat contains a great number of positive charge carriers, it's a P-type defeat, and if it has a large number of negative charge carriers, it's called N-type defeat. In the long channel of semiconductor material, oxide contacts at its end are cracked to form the source and drain connection. A p-n junction is formed in one of both sides of the channel. Characteristic of defeat. A defeat is biased through a variable DC supply, which will control the VGS of a defeat. We'll also apply a voltage across the drain and source. Using the variable VGS, we can plot the IV curve of a defeat. We can see three graphs for three different values of VGS voltage: 0 voltage, negative 2 voltage, and negative 4 voltage. There are three different regions: oxide, saturation, and breakdown region. During the oxide region, the defeat acts like a voltage control resistor where the current flow is controlled by voltage applied to it. After that, the defeat gets into the saturation region where the curve is almost straight. That means the current flow is stable enough where the VDS will not interfere with the current flow. But when the VDS is much more than the tolerance, the defeat gets into the breakdown mode where the current flow is uncontrolled. This IV curve is almost the same for the P-channel defeat too, but there are a few different axes. The defeat will go into a cut-off mode when VGS and pinch voltage or VP is same. Also, as is the above curve, for N-channel defeat, the drain current increases when the VGS increases, but for the P-channel defeat, the drain current decreases when the VGS increases. Example calculation of defeat. The equation want to determine ID and VGS. For solution, we must find the ID first with using the formula current equal voltage height minus voltage lower divided resistance, which is 12 voltage minus 7 voltage divided 3.3 kilo ohm, and the answer is 1.52 2.2 milliampere. After that, we must find the Vs with using voltage equal current multiplied resistance, which is 1.52 milliampere multiplied 2.2 kilo ohm, and also for Vs is 3.34 voltage. For Vg, we can use formula resistance 2 divide resistance 1 plus resistance 2 multiply voltage total, which is 1.0 milliohm divided 0.9 milliohm multiply 12 voltage equal to 1.4 volt minus Vs, which is 1.4 voltage minus 3.3 voltage, and the answer for VGS is negative 1.8 voltage.